Please click on subscribe button and click on bell icon for more interesting updates on civil engineering concepts. Hello friends, welcome back to my YouTube channel. For more information regarding civil engineering concepts, please follow our website civilbasics123.blogspot.com. I will provide you the website link in the below description of this video. I will post at least one article per 2 days. Please follow our blog civilbasics123.blogspot.com. In this video lecture, I will explain you analysis and designing of library building by using Staad Pro V8i software, which is related to the G+7 building model. Okay. So initially I will do the modeling process and analysis process and designing process for the respected library building. So firstly, I will show you the typical floor plan for the respected library building. So click on this PDF option. So click on the parking area. So this is a parking area for the library section. It will be consisting of parking area and column sections and staircases as well as lift provision. Okay, which is consisting of 1, 2, 3, 4, 5, 6, 7 multiplied by 4, which is approximately equal to 28 number of the columns will be exist for the library building. Okay. Again, in the same process, I will show you the ground floor plan. So this is the ground floor plan. It will be consisting of main entry section here and main library section here. And this is the wide walk, and this is the book storeroom, and this is the newspaper reading section. Okay. Again, it will be consisting of staircases as well as lift provision. So click on the remaining floor plan. So this is the remaining floor plan. For this respected section, it will be consisting of the digital library on the right hand side section and reading rooms on the left hand side section. Okay. Depends upon the usage for the respected typical floor plan. The values will be changes here. Okay. So firstly, initially we need to measure the center to center distance between the columns. So initially I will show you the typical floor plan for the column layout diagram. So click on the column layout diagram. So this is the column layout diagram for the respected library building. So it will be consisting of approximately of 15 feet, 15 feet, 15 feet 6 inches, 15 feet and 13 feet. And this is 16 feet 6 inches, 7 feet 3 inches and 15 feet 3 inches here. Okay. Go to click on the Staad Pro V8i software here initially. The software will be open here. So click on the new project option. Select the spacing option. So in this we need to select the file name. Just I am taking it as library lib. So select your folder here. Just I am selecting my folder to the desktop, which is consisting of library section lib. Click on OK. So in this we need to select the length units will be in meter and force units will be kilonewton. Why? Because as per the Indian standard system we need to consider. Click on the next option. Click on the finish option. So here the grid lines will be open here like this. So firstly we need to model the library building section. So for that, go to geometry option. Click on the run structure wizard option. So in this we need to consider the frame section models from the truss models. So here it was selected with truss models here. Select the frame section model. Select the bay frame option. So firstly we have to enter the length of the building. Initially we need to measure the column to column distance from the starting point to ending point. So it will be consisting of approximately, as per my calculation, 22.403 length. Again we have to assume the height of the building. So for this respective section it will be consisting of G+7 story building model. Just I am assuming. So which is approximately equal to plinth level plus ground story level plus 7 story, which is equals to 9 multiplied by 3, which is equals to 27 meter. And width of the building, just we have to assume here as per the calculation, 11.963. So now we have to enter the number of bays along length direction. So now here we have to enter the number of bays along length direction, which is consisting of approximately 5 numbers here. And height direction will be consisting of 9 numbers here. Again width direction will be consisting of approximately 3 here. Okay. So click on the 3 dots option in order to enter the proper length direction. So here I am assuming the length will be consisting of 4.572 for the first section. Again it will be consisting of 4.572 for the second section. In the same process it will be consisting of the third section of 4.724. Again for the fourth section it will be consisting of approximately of 4.572. For the last section it will be consisting of 3.962. Okay. So click on the OK option. Now we have to select this 3 dots option. In the same process we have to enter the z direction distance also. So for the first direction distance it will be consisting of 5.105. For the second section it will be consisting of approximately 2.210, and last section which is consisting of approximately 4.648. Click on OK option. So click on apply option. So the beam sections and column sections will be open here like this. Firstly we have to cancel this option. Click on S option. So click on OK option so that the model will be directly imported to Staad Pro software here. So after that we have to model the slab section for the building structure. So for that firstly we have to cut the section. Go to click on the cut section command, select to view, click on OK for the ground story section. So here I am selecting here. So now we have to add the slab section for this portion. As per my assumption, just I am going with the slab section of 4 node plate. So if you are okay with generate surface meshing, you can directly go with the generate surface meshing option also. So here I am selecting the add 4 node plate option. Select the first point, select the second point, select the third point. Again in the same process, select the fourth point. In the same process, we had to model the 4 node plate for the respected remaining section of the building structure. So after that, click on host structure command. So now we have to select the plate cursor, select all the plates. Now we have to copy these respected plates to the remaining section. Go to transitional repeat for that. In Y direction extends. So it will be consisting of number of steps of 7 and each step will be consisting of 3 meter. Click on OK so that it will copy the respected plates to the remaining section. So after copying all the plates, we need to place the shear wall section for the building structure. Okay. So for that, firstly we have to select the top view. So here I am selecting this portion. Again I am selecting this portion. So click on insert a node point which is at midpoint section. Okay, click on OK option so that it will add the node point section at the mid section. So now we have to measure the distance for the respected section, horizontal and vertical. Display option here. Select the starting point, select the ending point. Again I am selecting the starting point here. Again I am selecting the ending point. So it will be consisting of approximately the distance of 2.362 in horizontal. Again it will be consisting of 2.553 in vertical. So here I am selecting the node cursor. Select this section. Click on the copy option. Click on the paste nodes which is in horizontal distance x direction which is consisting of minus 2.362 here. Click on OK option. So it will copy your respective node point here like this. So now we have to add the shear wall section for this portion. So go to cut section command, click on select to view option, click on OK. So here I am cutting this respected portion for the shear wall purpose. Click on OK. So now we have to add the shear wall for this respected section. So for that here I am selecting the add surface section. So firstly we have to select the starting point here. Again I am selecting the second point here like this. So we have to give the no need to give the shear wall section for the plinth level. So click on the third point. Again I am selecting the fourth point. Again I am selecting the first point. In the same process we have to give the shear wall for the back side also. Select the second point here. Again I am selecting the third point here. Again I am selecting the fourth point here. Again I am coming to the first point. First point, second point, select the third point, select the fourth point. Again I am coming to the first point here. Okay. So after that we have to click on the host structure command. So now we have to see the rendering view. Click on the 3D rendering view option. So this is the 3D rendering view for this respected building structure. Okay. So after modeling process is completed, we need to give the properties for the beams column section. Go to general option for that. Click on the define option. Select the rectangular property. So as per my assumption, just I am taking 0.35 cross 0.35 is the beam size for the building structure. Again I am taking 0.5 cross 0.5 is the column size for the building structure. Click on add, close. Select the thickness option. So here I am selecting the plate thickness which is related to the slab thickness which is consisting of 150 mm, and surface thickness just I am taking here as 120 mm. Click on add, close. Select the beams option. Go to select option. Firstly we have to select the beams parallel to X condition system, beams parallel to Z condition system. Click on assign to selected beams, assign yes option. Again I am selecting 0.5. Go to select beams parallel to Y condition system, assign to selected beams, assign yes option. Select the plate thickness, assign to view, assign yes option. Surface thickness also assign to view, assign yes option. So after assigning all the properties, we need to assign the supports. Select the support condition system with the front view. So initially we need to create the fixed supports. Click on add here. Select the support 2. Select all the node points at the base condition system. Click on assign to selected nodes, assign yes option. So after applying all the support condition system, we need to apply the loading condition. Okay. So go to loads and definition. So firstly we have to define the loads which is related to the seismic condition as well as wind load condition system. So firstly I am selecting the seismic definition option. Click on add button. So in this initially we need to select the IS codal provision which is related to the 1893 codebook. So here I am taking 1893. So firstly we have to create the zone. So click on the generate option. So as per my consideration, just I am taking this library building was located in example of quota zone which is related to the Rajasthan state. Okay, so initially we need to select the city here. So again we have to select the quota. Just I am selecting the, as per the list, just I am taking here as quota zone. Okay, which is comes under 0.10 low seismic zone, which is having 0.10 factor. Okay, so again I am selecting the response reduction factor is 5 and all general buildings. And other parameters, it will be consisting of the 3 types here, which is related to the hard soil condition, medium soil condition, soft soil condition. Basically in Rajasthan quota zone, most of the soil conditions will be comes under the medium soil or hard soil condition. So that's why just I am normally selecting here as medium soil only. Okay, so click on the generate option. Okay, depends upon your considerations of the soil, you can consider. Okay, so click on the generate option so that the properties will be generated here. So firstly we have to enter the damping ratio 0.05. Why? Because we need to consider the damping ratio is 5%. Click on add. So after adding this respective property, we need to add the self-weight condition firstly. Okay, so after adding the self-weight condition, we need to add the member weights. So member weights are calculated depends upon the external wall loads, internal wall loads, as well as the parapet wall loads. Okay, so initially we need to calculate the load condition system. Okay, firstly I will calculate the external wall condition system. So for this respected building, just I am assuming external wall will be consisting of 0.23 thickness. So multiplied by your respected unit weight of the brickwork multiplied by each floor height, which is comes under the value of 13.8 as the external wall load. Again internal wall load will be consisting of 0.125 multiplied by approximately of 20 unit weight of the brickwork multiplied by each floor height, which is comes under the value of 7.5. In the same process I will calculate the parapet wall load 0.125 multiplied by 20 multiplied by 1.2 meter height. Just I am taking here as 3 value. So now we have to add all these values, which is related to the 3 plus 7.5 for the internal wall load plus 13.8 for the respected external wall load, which is comes under the load of 24.3. So here I am adding the weight which is related to the 24.3. So click on add option. So after adding this, we need to add the floor weight condition system also. So as per the floor weight condition system, we need to take load which is comes under the tiles and marble sections. So basically we will consider the values 2. Okay, so as per considerations, so we need to enter the Y range values also. So the first slab was located at meter of 6 meter and last slab was located at a distance of 27 meter. So click on the add option so that the load will be added here. Now we have to select the uniform load. Firstly we have to select the beams parallel to X condition system. Select the beams parallel to Z condition system. Click on assign to selected beams, assign option, yes option. So it will apply the load here like this. So after this we need to define the wind loading condition system. So click on the add option here. So select the add wind 1 type 1. Select the wind 1 type 1. Click on add. So firstly we have to calculate the intensity for the respected height. So I was already explained how to calculate the wind intensity as per 875 code book. So initially I will provide the video link in above cot link. You can follow that video. Okay. So as per my assumption, just I am taking simple values here. 2 which is acting at a distance of 27 and 1.5 kilonewton per meter square which is acting at a distance of, let us consider 18. Next I am taking 1 which is acting at a distance of 9, 0.5 which is acting at a distance of 3 meter. Click on add option. Now we have to add the exposure as 1, add option, close option. So after that we have to select the exposure, assign to view, assign yes option. Now we have to define the load case details. Okay, so after defining the loads, we need to define the load case details which is comes under the gravitational loading condition system as well as the lateral loading condition system. So click on add option. So firstly we have to define the seismic loading condition. Why? Because initially we are defined the load which is comes under the earthquake load only. So that's why I am taking earthquake load which is in X condition system. Again in the same process, just I am taking earthquake load which is related to the Z condition system. In the same process, just I am taking the wind loading condition system. So here I am selecting the wind load. So wind which is in X direction distance, again wind which is in Z direction condition. So after that we have to define the gravitational load which is related to the dead loading condition, again which is related to the live loading condition, LL add option. So firstly we have to select the earthquake load, click on add button. So in this we need to select the seismic loading condition which is in X with factor 1. Click on add, close, select the earthquake load Z direction condition. Select the load which is related to the seismic condition again here. So here I am selecting the seismic which is in Z condition. Click on add, close. Select the wind X, click on add button. Select the wind loading condition system here which is related to the X with factor 1, add button. Again I am selecting the factor as -1, add button. So select the wind load which is in Z, add button. Firstly, we have to select the wind load here. Again in Z direction, wind facing direction, add here. Again factor as -1, add here. So again we have to select the dead loading condition. Under the dead loading condition, we need to enter the values which is related to the self-weight condition system and external wall, internal wall, as well as the parapet wall load with floor load condition. So firstly, initially I will add the self-weight condition. So after that we have to select the member load which is related to the -24.3. So I was already calculated while defining the seismic loading condition. So we need to select in ZY condition, add button. Again I am selecting the floor load which is related to the -2, which is acting at a distance of 3 meter and 27. Sorry, not 3 meter. Here we have to take here as 6 meter. Okay. So click on add option. So again we have to close the option. Okay. So select the self-weight by using assign to view, assign yes option. Again in the same process we have to select the uniform load. Go to select option, beams parallel to X condition system. Again you have to select the beams parallel to Z condition system. Click on assign to selected beams option, assign option, yes option. Go to select the live loading condition, click on add option. So as per the IS 875 codal provision which is related to the gravitational loading condition, the live load condition which is comes under educational building we will consider as 3 kN per meter square. You can watch the table on the IS 875 code book which is related to the gravitational loading condition. So that's why I'm selecting here as floor load which is related to the -3 which is at a distance of 6 meter and this is the 27 meter. Click on add option, close option. So after that we have to select the load combinations. Go to select the add load cases details, click on add option, select the load combination, auto load combination as per the Indian provision only. Okay. So click on generate load combination, click on add option, click on OK option so that it will add the load combinations here like this. So after that go to select the materials, select the concrete by using assign to view option, assign option, yes option. So after that go to analysis and print option. So click on add button, close button, go to analyze option here, click on the run analysis option, click on save option. So here we have to check for the zero errors for the respected building structure under consideration. So here my model is checking for the zero errors for the respected structure. So now we can see here my model observed with 0 errors, but it is getting around 21 errors. You can reduce that errors as per your consideration. So I will provide you the how to reduce the warnings in Staad Pro software. Okay, in above Kotlin you can watch from this. Okay, go to post processing mode option, click on done option. So click on apply all load cases, click on OK, so that it will show you the deflection diagram under considerations of the live loading condition. So you can select any one of the load cases for the respected deflection. So select the Fy value which is related to the shear force diagram structure. Okay, so this is a shear force diagram for the live loading condition system. You can change that to dead loading condition system. Again in the same process you have to select the MZ value. So this is the bending moment diagram for the structure of the library building. So go to select the surface pressure, apply your stress type is absolute pressure, click on apply option, click on OK. So this is the maximum absolute pressure for the respected building. Now we have to design this respected building as per IS codal provision. Go to select the modeling, click on the design option for that. Firstly we have to select the concrete design and select the IS 456 code here. Firstly we have to select the parameters. In this initially I am deselecting all the parameters. So from this we need to select the compressed strength, yield strength of shear reinforcement, maximum main, maximum secondary. So if you want you can select the MD1, MD2 also. Click on OK. Define parameters. So here as per my consideration just I am taking M25 grade concrete 25,000, click on add. Fi section which is related to the 415 415 grade steel, click on add. Again I am selecting the shear section yield strength also, just I am taking 415 click on add option. Select the maximum main, just I am taking here as 60 mm diameter, secondary 12 mm diameter, click on add. MD1 just I am taking here as 12 mm diameter, click on add. MD2 also 12 mm diameter, click on add, close option. Okay, so after that we have to select the commands option. So in this I am selecting design beam, click on add, design column, click on add, design slab element, click on add, take off command, click on add, close option. Okay, so again in the same process we have to assign all the question marks. Go to select FC by using assign to view, assign yes option. Select the Fi main by using assign to view, assign yes option. Select Fi section reinforcement, assign to view, assign yes option. Maximum main by using assign to view, assign yes option. Maximum secondary by using assign to view, assign yes option. Select MD1, select assign to view option, assign yes option. MD2 assign to view option, assign yes option. Select the design beam command option. go to select option, beams parallel to X condition system, as well as we have to select the beams parallel to Z condition system. Click on assign to selected beams, assign yes, select the columns, go to select beams parallel to Y condition, click on assign to selected beams, assign yes, select the design element by using assign to view, assign yes option. So after that, go to analysis and print, add or no print, close option, go to analyze option, run analysis, save it. Okay, so again here we have to check for the zero errors as per the design considerations also. So now you can see here my model is checking for the zero errors as per the design of the building for the M25 grade concrete as well as Fe415 grade steel. So now we can see here my model is observed with zero errors and it is obtained with the 405 warnings. Okay, so I will explain you how to reduce this respected warnings. Go to post processing mode option, click on done option. Okay, so click on the beam option here, beam cursor, deselect the deflection diagram, select any one of the beam for the respective plinth section. So click on the concrete design. So now we can see for the plinth section, it is consisting of 7 bars of 16 mm diameter and the bottom reinforcement will be consisting of 4 bars of 12 mm diameter for the respected M25 grade concrete Fe415 grade steel. Okay, again it will be consisting of the column reinforcement section also. Firstly, I will show you the beam reinforcement section. So click on the concrete section. So for this respected section, it is consisting of 6 bars of 60 mm diameter at the top reinforcement section. Again, it will be consisting of 6 bars of 10 mm diameter at the bottom reinforcement section under consideration. Okay. In the same process, we have to select any one of the column. This time selecting this column. Click on the concrete design. So now we can see. So for this respected concrete design column section, it will be consisting of 20 number of the 12 mm diameter bar and ST percentage is taken as 0.90 and ST requirement is taken as 2000 mm square under considerations of M25 grade concrete and Fe415 grade steel. Okay, in the same process you can see the results for the respective remaining property for the beam sections and column section for the building section. Okay, so if you want to reduce the warnings for the respected building section, you can change the dimensions of the beams and column section to the higher value. So as per our consideration, just we are taking the 0.35 cross 0.35 for the beam, 0.45 cross 0.5 cross for the column section. Okay, so if you want to reduce the warnings, you need to increase the dimensions of the sections. Why? Because the dimensions of the section will be not sufficient as per the reinforcement values which is obtained from the Staad Pro here. So that's why we need to increase the dimensions of your respected property. Okay, so that you can reduce the warnings. Okay, so this is the process. Complete analysis and designing of library building which is related to the G+7 building structure in Kota zone, Rajasthan by using Staad Pro V8i software. So if you have any queries about this respected video, please try to text me your questions in the below comment box. I will try to give the answer for that respected questions. If you need the more information regarding the civil engineering concepts, please follow our website civilbasics123.blogspot.com. Thank you.